Okay, so I'm going to talk about optimizing black box builds. This is a title that doesn't make any sense. So I was just away in Paris for the weekend at a .scale conference, and I made these slides on the flight home and the taxi here. So this is a talk about how to build what you don't know. So I'm Ross, I work at Digit Game Studios. We make video games. We're a really small company, but I'm the lead release engineer there. And I'm trying to bring some organization to the chaos of releasing games. I'm going to talk about specifically making client builds. For our back-end and platform teams, we use GitLab CI, which is similar to Travis. It uses pipelines, and you define everything in YAML, and it just keeps everything up for you. But our client development process is complicated, of course, because of a bunch of reasons. So we use Unity, which is a game development, sort of cross-platform targeting system, and we make mobile games targeting Android and iOS. So because we're building to iOS, we need to build on OS X machines, which are, disclaimer here, they are all pets, every last one of them. I've tried to turn them into cattle, but that's a long process as well. So the next thing is, one of my friends said this to me once, that the fastest way to do something is not at all. And this is something that's stuck with me for the last few years. And that's really what this talk is going to be about. It's like, don't make things faster, just don't do them. I think that is just the way to go. And unfortunately, in game development, there's this thing called asset bundles. So in game development, we have all of our code, which is nicely organized in C#, and we've got thousands of files, which is a nightmare in its own right. But we also have to consider, how do we build all of the art and animations that our creative teams are making. And asset bundles are actually a pretty cool technology where you can wrap up some art and stream it over the internet like a YouTube video onto a mobile phone. So someone will only download like 100 megabyte app, but then you can stream in like gigabytes of content on top of that, just like whenever they're connected to the internet. So asset bundles, it turns out, are a major pain, because you need all of the assets available at build time, and it's a super expensive build. And although we're creating little tiny actual installable artifacts, we're creating gigabytes of data on every build. So identifying a pipeline. When I started looking at this, it was a bit of a mess. So I'm going to talk about Kings of the Realm, which is a game that we've got out in production already, and kind of go through the process that I went through in my mind when I was faced with, here's what a game development build looks like, and make it faster. So Unity is its own sort of can of worms. I'm not really going to get too much into that. You can build by a command line. That's all we need, really. Although it can't be in a headless machine, which is annoying. So you can't build headlessly, but you can log into a machine and then connect a Jenkins minion to a master, and it'll work the same way as if it had a GUI. Little caveat there that I learned. So we build for Android and iOS. The way that it started was if you consider this a Jenkins pipeline, the way that we used to build it was we'd fire up an Android build, because that builds at about 3 minutes faster than an iOS build, so you get faster response. And then we'd do an iOS build sequentially. So I looked at that and I was like, well, it doesn't sound great. You know, what else is going on here? So it turns out that after this stage, so yeah, we'll build an Android device. We build the asset bundles, which create a whole bunch of binary objects, and then we upload every one of those objects to Amazon S3, some cloud storage, which we can then just fetch them off the internet on the device themselves. And then after building all of the Android, and if it fails, fail early, we don't have to go ahead and do iOS. We'll then build iOS. So this whole process was taking about an hour end to end, because it was sequential, but also it would fail super early and not really waste resources by doing them in parallel. So developing a pipeline, the building blocks of this is don't ever do anything sequentially. Why bother? So I had a look at this again, and I was like, well, let's turn this into 2 jobs. We have one Android job and one iOS job, and similarly, we'll build the asset bundles after that, and we'll do the upload. The thing that's really important here is to break down the big unknowns into smaller stages, right? So avoid the work that you just don't have to do. Asset bundles are created by the art team, and realistically we've got like thousands and thousands of art assets. Not every one of those is going to change on every commit, So obviously automate all the things. That's always, that's why we're here, I suppose. The thing that's really important is in this picture here, your code's going to change more often than not, because these jobs are being built on every code change, right? So these are the things that are going to happen every build. Asset bundles are infrequently changing. The way that...
Is the way you build an asset bundle for Android different to the way you build it for iOS?
Interesting question. So, yes.
Okay.
You have the same source files for assets, like they're, mega PNG files or whatever. They're normally super high quality,
yeah.
And we actually split them out into like high quality, medium quality, and low quality for a range of different screen sizes. But for Android, interestingly, Android supports a subset of a bunch of different compression techniques and formats, and iOS supports all the other ones. But there's no crossover there, of course, because why would that be useful? And actually a lot of that has to do with the types of formats that Unity supports creating. There's no real overlap there. So so we're not able to use the same asset bundles for different platforms. And we also build to WebGL, and that's another platform for asset bundles as well, which is a nightmare, but just wanted to keep it kind of simple for this. So because asset bundles are infrequently changing, we can maybe build these. We don't know if we're going to have to build all of these asset bundles every commit. So what you can do is, just through observation, you can say, well, hang on, we've only got X number of changes to X number of files in this build. Why are we going ahead and rebuilding all of these assets? So this uses, well, for various reasons, people are scared of building in the same workspace. I'm a huge advocate of caching. If you know that keeping something in the workspace isn't going to have any negative impacts, then absolutely, why wouldn't you do that? So in the case with Unity, it assumes that you're just a single developer on your one machine, and your workspace is never going to change, nothing bad's going to happen to it, and it interestingly scans all of your files, imports them to its own Unity format locally called a library folder, which is indecipherable and cannot be modified ever, or else, boom, you have to import everything again. Very frustrating. But with asset bundles, you can say, well, instead of building all of these asset bundles and like the tens of gigabytes of data that we want to, crunch into something meaningful for the client, just build me the ones that have changed. So you can totally do that, and it's like an inbuilt feature with Unity and asset bundles, because we build each asset into its own asset bundle. So we've got like 6,000 assets, they each get their asset bundle. So whenever you come down to a new build, you can say, well, only 5 assets changed this time, I only need to build 5. So then you can go to the upload step, and you can say, well, hang on here. I've only built 5 new assets. Why do I have to upload all of them again? All right? So it's a 2-stage process. You can say, I'm going to cache the workspace and only have the delta per build, and build that. So your time to process all this files is kind of way down. But with uploading, Amazon provides like some CLI tools which are pretty comprehensive. But there's no real way to speed up uploading gigabytes and gigabytes of data to S3. You can compress things. That doesn't really help the problem. You're still doing the effort, right? So what I found was that Amazon S3 can copy files from Amazon S3 faster than I can upload them from some random place, right? I mean, we use Amazon in Ireland or whatever, so that's fine. But as long as there's some files in S3 somewhere, regardless of how close they are to what our desired state is, if it's over 50% correct, it's worth just copying them over and then overwriting whatever has changed. So I found that in this process, instead of just uploading them direct, I could do an Amazon CLI call and just say, copy the ones that you've already got, and then I'm going to upload the different ones. So there's a lot of like file system scanning here, and Amazon has its own checksum way of figuring out which ones changed and which ones have not, and which ones are newer. But that relies on asset bundles being deterministic in their production, right? Which is fine, they are, which is useful, I guess. So this turns into something more like this in terms of like the time breakdown, because you can get, instead of your asset bundles taking up nearly all of the time, suddenly they're taking up like way less time because you're skipping nearly all of the effort. And then uploading takes way less time as well because you're skipping nearly all of the effort. But offloading the copying of these asset bundles to the server at the time that you want to upload them is kind of like, why can't we just have an infinite number of places to put these that are already pre-populated? So what I looked at here was, during the night, no one's really working most of the time, so that's fine. We've got people around the world, which is fine. But generally, when people are not running a build, we could just be pre-populating with the latest content all of these asset bundles. So what I started to do is asynchronously just copying across these things sort of 10 ahead of time or whatever, so that by the time that it comes to upload, you basically don't even need to upload anything. You only need to upload the ones that you've just built. So it brings uploading, let's call it 10 gigabytes of data on every build, down to uploading about 2 or 3 megabytes of data. And all of a sudden, builds went from, you know, like, it was 1 hour when everything was sequential, 36-ish minutes when we ran those two in parallel, to about 8 minutes now. So, huge wins for essentially not going into how does C# work. I still don't know. I still haven't really looked into how are we building these asset bundles. And the only thing that I've changed was how do we manage the workspace and how do we manage the artifacts. And that's one way of like breaking down what seems, what is quite a complex build process, which just generates some stuff, and turning it into something that's still complex and still generates stuff, but something that's way more easy to manage in terms of the actual cost involved. So the takeaways here are really cache absolutely everything that doesn't change, because why not? And yeah, here's the main takeaway. So cache. Start simple. Learn what changes. Cache everything everywhere, because even in the case where you don't have, like let's say that you're spinning up Jenkins minions totally bare. You don't have to do that. You could be spinning up a minion, copying across a pre-cached version of a workspace, and then utilizing that. So most of the time, network costs are actually going to be less than your big compile costs, which is something that you don't think is going to be the case. But inside the context of a data center, networking is way faster than compiling like a bunch of files, or you know, even cloning a massive repo. So, I mean, for example, our game is we store everything in Git, and it's about like 60 gigabytes, the repository size. It is it's so big that the default timeout in Git just isn't big enough, which means that, you know, turning this onto like some third-party build system is not an option for us. And because of the way that, I guess, like, you know, our project is, and the nature of the large binary ASCII files, just using the network bandwidth that we have available to us is way, way, way cheaper than waiting for a massive compile to happen. So that's it for the talk. However, I am running a build and release conference in August called ShipItCon. It's about shipping software safely and in a responsible way. We're going to have like a bunch of speakers from a bunch of different areas, from a bunch of countries, all talking about how they see the release process and who's involved in that, and all sorts of interesting stories. So I definitely encourage you guys to come along. Seems like you're all interested in that kind of how do we ship mentality, and how do we provide value to customers through the act of delivering software. And yeah, that's it for me. So I'm really interested in all the questions.